Hi guys, my name is Manish Kumar. So in the last video, we talked about some data points we have corresponding to person height and weight, and we try to draw a line. And that was more theoretical session where we majorly talked about how you in a person will do this exercise. Now let's think mathematically how can we do it. If we can figure out a formula to find the right place for this line, then we can feed that formula for computer and computer can help us out in this. Very simple thing. We'll just put it up there and create a clear graph for these data points what we have up there. So just give me a second, I'll be back. So this was the graph and our goal is to draw a line close to these all 4 points. That's our goal. So how to do it, guys? So let's say we begin something from here, right from here, let's say. And to simplify this, first just move the line up and down. We will not change the slope of the line. So we know that the equation of line is y is equal to mx plus c. And what is our goal? Our goal is to reduce this error from each points, like all these points. Error 1, error 2, error 3, error 4, because here we have 4 data points. So all errors, these errors should be minimum. That will be all. So as I said, to simplify this problem here, I said that we will keep our slope constant. We not gonna change the slope. We will change only the position of the line. We will move it up and down on y-axis the line. So basically we will change the intercept. So c is like intercept in this equation, we know that, and m is the slope. So we are not going to change the slope and we will just play with intercept. Okay, so let's try to do it. Let me move this to a side just to have some space here, and then let's start doing it. So what we will do, we have y equal to mx plus c. That's our equation, right? And just so we know that our data point 1 is, let's say, x1, y1, x2, y2, x3, y3, and x4, y4. So how to see the error? We draw a line. We started with c equal to 0, which is like from the origin. So what we see here, we see the error 1 with first data point. Let's call it E1. E1 is equal to coming out as the y1, the observed value, minus m x1 plus c1, right? This is our first error coming out. Similarly, error 2 will be y2 minus mx2 plus c1, and error 3 will be this distance, like the y3 minus mx3 plus c1, and so on. So all error 1, E1, E2, E3, E4, we can easily calculate these values. Now our goal is to minimize this. So what we need to do, we need to, let me just complete this, is equal to y3 minus x3 plus c1, E4 is y4 minus m x4 plus c1. So let me move these errors here. Our sum of error will be, let's call it SOE, will be E1 plus E2 plus E3 plus E4. This is our sum of error. So our goal is to minimize sum of error. So how it will work, like if you will see, as the line goes closer to this, this is getting reduced, all the errors getting reduced. But once the line will be up here somewhere, let's say If the line will be somewhere here, then our error will be negative, will start getting negative now based on our formula. So to simplify this, what we can do the square of error. So let summation of error square equal to, let's say, I equal to 1 to 4, we have 4 data point here, and I say ei. Now I know the formula here, that summation of error square is equal to, this will be square of each error. This is my simple like formula of this. So to simplify, if you see the graph of this, how the graph will look like for this summation of error. This is a square. This line, the error is this much. Now we will take the C little more up here, then the error will be less. So as C is going up close to the points, the error is going down like this. So the graph will be something like this. Because it's a square, so it will now go negative, it will start going again into the another side of positive direction. So sum of a square, so basically on this x-axis it is C, and on the y-axis this is sum of error square. This is what the graph is. It will. So now our goal is to find out this point where the error is the least error, this point. And as you can see, I draw a line, a tangent line for this point. So tangent should be 0. That's our goal now for this parabola. This is a parabola, right? This image, we know that in the math. So it's a y equal to ax square plus bx plus c, and the tip of this will have the tangent 0. And to calculate the tangent, we know the formula we have is the derivative. So derivative of what we are saying, s of e square corresponding to derivative of what is on the x-axis, this is c. Derivative of corresponding to c is equal to derivative of this. So the value will come out to be, if I will see even error, what is even? Even is the, if you will see, error is the observed value, this is observed value, and the predicted value, and the difference of them. So if I put the formula and I put inside the equation, if I put here observed value, we said observed value OD, and predicted value PD square. So basically we said the observed value and the predicted value, difference of them is the error and square of it, and if we derivative it with the c, that will be our tangent value, and our goal will be to minimize that value, right? So now if you will see, what is PD, predicted value is, if I write it here, predicted value is actually m x plus c I. For every point we are changing the c, having m constant as we decided earlier, and we are like calculating the value. We are finding what is our prediction. So based on c. So this is our, so what we will do here, we will do 2 OD observed value, this is a constant, simple. So if you calculate it, it will come out to be 2. Let me take out the summation here. 2 OD minus PD. Now derivative of OD correspond to C will be 0 minus dPD by dC. Now what is dPD by dC? dPD by dC will come out here. If you will see dPD by dC in this equation, this part does not have C, so this will be 0, plus it has C, and corresponding to the derivative of C corresponding to C will be 1. So actually this value is 1. So this is coming out to be summation I equal to 1 to 4 to OD minus PD, observed value minus predicted value, into minus 1. which means to simplify the calculation, this is I equal to 1 to 4 minus 2 OD minus observed value minus predicted value. Now we know what is our goal. Our goal is to reduce this error. Now, so if I move this to a side, little bit here, and I just keep this equation here to make cleaner. So basically we said d sum of error square derivative to dc is equal to all observed point, which is we have 4 in this case, minus 2 observed data point minus predicted data point. This is our equation. So now we know the PD is like this PD, this is m x plus c, and we are changing c and correspondingly we are calculating this. I am saying formula for it in terms of math, which will help us to figure out what will be the closest location for this line. Now, if you will simply write a code where you will tell your system that start from c equal to 0, use this formula and keep increasing c with a certain rate, and what that rate will be? That rate will be called as the learning rate. Learning rate, if you will keep increasing value of c with a learning rate and then keep evaluating what is my error value now and go up to the point where you will define your endpoint. Endpoint could be anything. Endpoint could be, it could be simply like go 100 attempts or 1000 attempts, sorry, not 100. Or maybe when the previous value of error minus new value of error is less than equal to 0.001. So you are saying that there are like, we are very close now, the further improvement is going very slow. So we can just live with this much error. This is our delta. Something like this. So you can define what is your end limit for this algo. So you begin with a random number. Generally most of the models begin with 0. So same thing you can do here. You can like say like, okay, c equal to 0, and from there you start finding this, what is my error square value coming out, and you keep changing the value c with this learning rate and keep finding it, and then you reach at a point and that is your line. Now you know the pattern. And once you know the pattern, you know the value of c, you can put the formula, the value in the formula, and like you can start predicting what will be your y. So this is kind of like the backend idea behind the simple example we did, how we will educate our machine, how the machine can help us in the prediction. And we did in a very simple case where we said the slope is constant but our intercept is changing. Now, if to make it a little more complex and to give a sense how much complexity involved in it, think like if we will say like, okay, slope will also change. Now what will you do? So basically what you gonna do here, you will try to tilt this line in such a way that it has to be close to all the points. So the error we found here was corresponding to C. Now what you will do? Basically the error, sum of error corresponding to slope also. That will be our goal. So if we can find out the formula for this, then our goal will be that error corresponding to changing C and error corresponding to changing slope should be minimum, and both combination we will keep running, changing the values and keep evaluating these values and figure out this is our minimum case. Simple. So how we will do it? Let's try this again. So we know that our error is OD, observed value minus predicted value. This was our error and we have summation again here. Then we go with the error square, which was summation of I equal to 1 to 4 and OD minus PD, observed value minus predicted value square. and then we took the derivative of error square with respect to slope now. So we are doing with respect to slope now. So if I just keep the summation here, OD minus PD square. OD is constant. We know, we already talked about that OD is a constant. So what we need to do here, we have PD, and what is PD? Let me write it here. PD is equal to mx plus c. This is my PD. You know that. Now, if I will do derivative of PD corresponding to slope, this is constant this time. This value is 0, and this value will be my dmx only, whatever the x parameter is, whatever my input is. This is x is actually the input. So we were inputting height. For this height, give me the weight. So 1 feet, 2 feet, 3 feet in each example, that is my input. So what we did here, if I come back to this, I will say like, okay, 2 will be constant, 2 will come out to be here, and let me put the summation sign. That is, it's going on for all data points. OD minus observed value minus predicted value into DPD by DM, and DPD by DM value is X. So this X value will come out here, and what it will come out to be summation I equal to 1 to 4 to OD minus predicted value into input value. Simple. So this is my formula came out, the new formula for this error, 2x1, 2xi or whatever input is, OD minus PD. So now I know that I have two things now. One is DSOE square by DC and DSOE square summation of error is derivative corresponding to slope. These both errors need to be minimum now. So I will try to find out the combination of different things, put the values into the formula, and I can figure out where I can get the minimum value of C and M. So that was the entire concept behind it. Once we reach out to this, so you can simply write a algo for it, write beginning from some random numbers for these, and then you can start changing them, keep feeding in. You can define the endpoint because it could be million times you have to run this calculation. Every time you run it and you do it. So this is the core concept behind it. So guys, here we talked a very interesting thing, the learning rate. What is learning rate? Up to this point, we know that we have to take these two values to its minimum, just so we reach a close to our observed value and our prediction will be more accurate. That we know. Now our goal is how can we optimize? So if you imagine this graph, what we talked here, and if you will be drawing the line for this and you begin with some point, you will keep increasing it slowly, maybe by increasing C 0.0001 or some value, and you will be going through million combinations of different slope and different intercept to figure out that where is my right point coming. Now our goal is how can we optimize this cost, and to optimize it, there the important things comes here is gradient descent. So basically these values, when we have more than one parameters to evaluate, these all are called the gradients. And now because we are thinking to descend these values, so that's why we call it gradient descent. Very simple. So what we need to do, what is gradient descent? Gradient descent says that when your gradient values are bigger, take big step to reach closer to observed values, gradients become smaller, keep reducing step size so that you can reach the right point. Your step size is getting reduced so that like you can easily reach. So once you are far from the line, you can take a big jump. So just to give an example here, let me draw this graph again here with this line here, and we calculate this error. We calculate this error, and I'm just taking again guys an example here that let's say the error value for this case comes 20. This is 20, and our learning rate, which is a constant we decide for the model, said like 0.1, 0.1. Now our step size will be error rate 20 into our learning rate 0.1, which is coming out to be 2. So what we need to do is we can take a step by 2. Next step could be C1 was 0 plus we can go 2 equal to 2. So we can go up to here at this point maybe. So our next line could be, and that is maybe here, this may be 2, and our next line could be here. And now our new errors will be this, 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 and this. This is a new error. So what we will do here now, if you will see, and if I do here next, now our error will be reduced drastically. So error may be now 5. So the step size will be 5 into learning rate, which is our 0.1 equal to 0.5. So earlier we took the 2 steps, now it is saying just go 2.5, which may be here, and we can say that okay, let's draw a line with 2.5 here. As you can see, now we have started drawing it, took the baby step. And which results, I'm just taking an example again. Let's say the error reduced now and it come out to be 2. So because our learning rate is 0.1, so step size will be 5 into 0.1, which will be 0.2, not 5, sorry, 2 into 0.1, which will be 0.2. So now we can take next step by more 0.2, which is like maybe at this point, and it could be something close to this line here. So basically what is the concept behind it? The gradient descent help us to reduce the overall cost of the learning. Yes, you can see we took big jump. Once we reach at the close to the right point, it started turning out to be baby step. If you will go with the fixed rate, let's say you decide and you say like, okay, every time I will go with 0.2 increase in the C. So then you will begin with 0, 0.2, 0.4, 0.6, 0.8 and up to 2, 2. So this is a big deal where you just took the 4 steps and now you are in a very small range of it. And now if you will keep, running for let's say 50 more steps or 100 more steps, you will reach at the right point. What do you need? What is your need? So that is the core concept, and that's called the gradient descent. And this is used a lot to build the neural network, to learn the model. So guys, in the next session we will talk a little more into this. We will like go more into the neural network, how that look like, how these things, what I call like here the input, outputs, gradient descents, all these things gonna be used over there, how that look like kind of thing. So in the next session we will talk about it. So just keep practicing, take an example of data, try to draw a pattern on your whiteboard. Take some samples, like I'm not saying you need to do write entire calculation, just simplify. Let's say, like for example, I took here error is coming 20. If you want to, you can just simply take some real numbers also, that's perfectly fine. I'm like not against it, but I don't think we are learning addition and subtraction here. So once you do more practice, you can visualize how actually the things are happening, and it will help you to learn these things even faster. So thank you so much guys to join the session, and see you in next session.